Have you ever wondered why two magnets repel or attract each other? Or why your hair stands on end when you rub a balloon against it? These are all examples of electrostatic interactions, and they're governed by a fundamental principle known as Coulomb's law. Imagine you're holding two electric charges. According to Coulomb's law, the force between these charges is directly proportional to the product of their magnitudes. In simpler terms, the larger the charges, the stronger the force between them. It's a little like how two big, strong people can push or pull harder than two small, weak ones. But that's not the only factor at play. The force between the charges is also inversely proportional to the square of the distance between them. This means that as the charges move further apart, the force between them decreases rapidly. Think about trying to hold a conversation in a noisy room. The further apart you are, the harder it is to hear each other. This is known as the inverse square law, and it's a key part of understanding how electrostatic forces work. But there's another aspect to consider: the nature of the charges themselves. Charges of opposite signs, one positive, one negative, attract each other. Meanwhile, charges of the same sign repel each other. It's a bit like how opposites attract in relationships, while too much similarity can lead to conflict. Coulomb's law also follows the principle of superposition. This means that if you have a charge that's being influenced by multiple other charges, the total force on that charge is the sum of the individual forces exerted by each charge. It's like being in a tug-of-war with several other people. The total force you feel is the combined effort of everyone else. By understanding Coulomb's law, we can explain a wide range of phenomena in nature and technology. It helps us understand how atoms behave, how electronic devices work, and even why lightning occurs. It's also the basis for studying capacitors, electric fields, and many other aspects of electromagnetism. In essence, Coulomb's law tells us that the force between two electric charges depends on their magnitude and the distance between them. It also tells us that like charges repel and unlike charges attract, and when multiple charges are involved, the total force on a charge is the sum of the individual forces from each of the other charges. So the next time you see a lightning bolt or feel static electricity, remember it's all thanks to Coulomb's law.